Hello everybody, we're going to continue our introduction to triangles here. We're going to talk about congruence, triangles, naming triangles, how you do that, corresponding parts, third angle theorem, properties of congruent triangles, and away we go. A lot of this is intuitive, makes sense. We just have to make sure that we're doing everything the correct way. Okay, definition of congruence, exactly the same size and exactly the same shape. Okay? Now we got a problem here because they're the same shape but they're not the same size, so it's not congruent. Okay, all the sides have to be the same length, and obviously these are not, even though it's the same shape. They're similar, but they're not the same size. And obviously this one's not congruent to this one because they're not even the same shape. Okay, same shape, same size. Now down here we do have two congruent figures, because if I were to take this figure and lay it on top of the other one, it's the exact same size and the exact same shape. Okay, so these are congruent. Exact same size, exact same shape. Hopefully that makes sense. Hopefully that's not a real tough concept to understand. Okay, now, when you name triangles, when you name polygons, whatever you're doing, order matters. Okay, if I'm going to tell you that this triangle is congruent to this triangle here, okay, I would say that triangle ABC is congruent to triangle, and I've got to make sure I go in the same order, naming the same angle. Okay, well this looks like a 90-degree angle here. I'll make it 90 degrees. I went A to B to C. So when I write the order for the next triangle, I've got to go from X to Y to Z in the exact same order. Triangle X, Y, Z. Okay? Same thing's going to hold true with polygons down here. Okay? If I say that pentagon LMNPQ is congruent to this other one, I'm going to have to start. I went LMNPQ. So I need to go from the same starting spot. So it's going to be F, E, I, J, K. Order matters. If you write it in the wrong order, it's going to be incorrect. Order matters. Order's a big deal. That's what you need to get out of this slide. Make sure you do things in the same order. Okay? Third angles theorem. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Well, let's think about this. If this angle is congruent to this one, okay, let's give it a number. Okay, it looks so cute. Let's call it 30 degrees. Okay, that means this one's 30 degrees because it told me they're the same. And I also know that this one's the same. Well, this one even looks a little smaller. We'll call it 20 degrees. Okay, this is 20 degrees. Well, since they're triangles, aren't both the interior angles of these triangles going to add up to 180 degrees? Well, what does that mean? If this is 30 and this is 20, what's left over here is going to be 130, which means it has to be the same thing as this. So basically, what that is telling you, if you know two angles of a triangle, you're going to be able to figure out the third. And if you know that two angles of a triangle are congruent to two angles of another triangle, then you know their third angles have to be congruent, because in every triangle, the angles have to add up to 180 degrees. Okay? Simple, good stuff. Hopefully this makes sense. Again, it's not real difficult stuff, but we do have to lay it out on paper and make sure we understand what we're talking about here. Give this a name, third angles theorem. Okay? Properties of congruent triangles. Okay, now we've had all these properties before. Okay, we've got the reflexive property. Okay, which means triangle ABC is congruent to triangle ABC. We know that. Any triangle is congruent to itself. Reflexive. We knew that. We had sides that were congruent to each other. Okay? The symmetric property. Okay? This says, okay, let's just change the order here. Let's go triangle BCA is congruent to triangle BXZY. Okay? just based on the letters I have here. Symmetric property says I can flip those around, right? So that's the same thing as saying triangle XZY is congruent to triangle BCA. I can flip the order of these. Symmetric property. We've had that all before. We're just applying it to triangles now. And the transitive property. Okay. If A equals B and B equals C, then A equals C. Okay. Now I need a third triangle here. Wasn't thinking here. I need a third one. So let's draw it. Okay. Whoop. So let's call this one L, M, N. Okay. So if triangle A, B, C is congruent to triangle, and if I go in the same order, YXZ, and triangle YXZ is congruent to triangle LMN, then that means that triangle ABC is congruent to triangle LMN. If A equals B and B equals C, then A equals C. Same idea, we're just applying it to triangles. Again, hopefully this was mostly review, but hopefully you understand what everything is. Definition of congruence. Okay, exactly the same size, exactly the same shape. Corresponding parts, make sure you name things in the correct order. Third angles theorem, if you know two angles are congruent in two different triangles, you know the third angles have to be congruent. And then the properties of congruent, reflexive, symmetric, and transitive properties. Okay, we will see you in class.